In this chapter, we're going to look at chemical change, which is making or breaking chemical bonds. In chemical change, because you're making or breaking chemical bonds, new molecules appear and old molecules disappear. So if you see something with a formula that wasn't the same as what you had before the chemical change occurred, you have a genuine chemical change. What if I take some water and I put it on the stove and I boil it and I get steam, H2O gas? Is that a chemical change? No, it really isn't, because I have H2O molecules before and H2O molecules after. Now notice what I've written down here. This is a sort of a shorthand for a chemical change called a chemical equation. But this isn't truly a chemical change because I have not made a new molecule. This would be called a physical change. When you change from a liquid to a gas, that's a physical change because you're rearranging the molecules. A chemical change would be actual new molecules. For example, suppose I had this happen. Now, this would genuinely be a chemical change because I have a formula, NaCl, appearing, which I did not have initially. Now, let's back up a little bit and see how I'm writing these chemical changes down. I'm using chemical equations, and on this side is what I have before the reaction. These are called the reactants. On this side, I have what is left after the reaction is complete, and these are called products. I have little symbols that I have put after some of the formulas of things that are involved in the reaction, and these are called state symbols. And sometimes you need to put them in, sometimes you don't. It depends on the job you're doing, whether they're important or not. It's always safe to put them in if you're not sure. State symbols are a little s in parentheses for solids, a little L for liquids, a G for gases, and then there's an AQ for aqueous. So there's a problem though with this little chemical equation that I wrote down, and if you've taken any high school chemistry at all, you might have recognized it right away. I've got 2 chlorines on this side and only 1 chlorine on that side. So somewhere in my equation I'm destroying a chlorine atom. A chemical change cannot create or destroy either mass or atoms. So if you're losing an atom in here somewhere, that's bad. You've written this equation down incorrectly. Rather, I have written this equation down incorrectly. Now I could fix it like this. I could say, well, I got 2 chlorines there. I need 2 chlorines on this side. What I can do is put a coefficient in front of that formula. Now I'm not going to put a Cl2 there because that changes the formula, that changes the compound. So I have to change the number of chlorines without changing the formula. So I'll put a 2 in front of there. And then that means that on this side I have 2 NaCl units. And that'll give me 2 sodiums and 2 chlorines. And now I fixed the problem with the chlorines. But I made a new problem for myself, because now I have 2 sodiums on this side and only 1 on this side. Well, I can go and change the coefficient here so that I have the same number of sodiums and the same number of chlorines on each side. So when I write an equation down like this, what I've just done to it is called balancing an equation. I say that I've balanced it if it has the same number of each type of atom on each side of the equation. For example, suppose I write down the equation for hydrogen gas reacts with, that's what the plus sign means, oxygen gas to give me H2O gas. And I want to balance this. Alright, now I've got 2 hydrogens here and 2 hydrogens here, so that looks fine. But I've only got 1 oxygen here, and I've got 2 oxygens there. So what can I do? Now, I can't just put a 2 there because that will change this into a different molecule. I have to leave it H2O. So what I could do to get 2 oxygens on this side is to put a 2 in front of that. And now there are 2 O's and 2 O's, but I've messed up the hydrogens, right? Now I have how many hydrogens? 4. I've got 4, 2 pair. So I need 4 on this side. If I put a 2 in front of that, that will fix it, and it will be balanced. So now in this equation I have 4 H's on each side and 2 O's on each side. Let's do another one like that. If I have CH4, which is natural gas, reacting with oxygen, burning in oxygen, that will give me carbon dioxide gas and liquid water. If I cool the reaction mixture back down to room temperature, I can write liquid water. Alright, let's balance this. Now, I can go back kind of randomly and balance it that way, but it often helps to look at whatever looks the most complicated. That is, what in this equation has got the most atoms in it that are unique? This one. This looks like the most complicated thing. And what I'm going to do to start off my balancing is put a 1 in front of there. Now you may have noticed that I don't write a 1 there, and I didn't write a 1 up here either. Usually when we have 1s in chemical equations, we don't write them in. So unless you're asked to write a 1 in there, don't write anything in there when you write this down, because people don't write 1s as coefficients in chemical equations, just like they don't write 1s as subscripts. I mean, this should be C1O2, but we don't write the 1 in there. Alright, so I put a 1 in front of the thing that's the most complicated. Now and then I ask myself, where does that take me? That gives me 1 carbon on this side. So what should I put here to balance that off? If I put a 1 there, that's going to be 1 carbon on this side and 1 carbon on that side. Now where else does this lead me? If I put a 1 in front of this, it means I have 4 hydrogens on this side. So what should I put here? In order to get 4 hydrogens from this, I have to put a 2 there. Now I have 2 times 2 is 4 hydrogens there. All right, the only thing left is the oxygen here. Let's figure out what we should put in front of that. Now I've got this side all nailed down, so I should know how many oxygens need to be on this side. There is 2 oxygens here from the 1 CO2, and there are 2 oxygens here from the 2 H2Os. So I have a total of 4 oxygens on this side. So I need to have 4 on this side. So what should I put there? A 2. Now that gives me the same number of atoms of each type. Now if I was going to write this down and show it to anyone, I would write it again without the 1s in there. So I would just kind of erase the 1s and write it that way. Let's do another one. It's going to look a little bit similar. Let's see. Here I'm burning ethylene. Now let's go by the same steps and we might get a different result here. If I put a 1 in front of the thing that looks the most complicated, that means there's 2 carbons on this side. So I would put a 2 there. Okay, and if I put a 1 in front of here, I have 4 hydrogens. So I would put a 2 here. So how many oxygens do I have on this side? I've got 2 times 2 is 4 here, plus 2 more is 6. So what should I put here? A 3. All right, let's do one more that's like that. Here I have propane. All of these are combustion reactions, where I'm taking a fuel and I'm burning it in oxygen. Let's balance this one. If I put a 1 in front of this to start off with, because that looks like the most complicated thing in the equation, there are now 3 carbons on this side. So I should put a 3 here. If I put a 1 in front of this, I should have 8 hydrogens. So I should put a 4 there. So now this side is nailed down. How many oxygens do I have on this side? I've got 6 plus 4 is 10. So I should have 10 oxygens on this side. What should I put there? If you said a 5. You're right. We'll pick this up in the next video.